All right, so now there are type of questions that they're going to give you. All right, types of questions you should expect. Let's just say type of questions. Type of questions. Type of questions you should expect. All right. Now, before we can get into the real type of question, the calculations, let's give you something you also need to know, the conversion. Normally, we say charges. Charges, their units are measured, I'm just giving you, the units are measured in C. The C is for the coulomb. Let's go back in time. The very same coulomb, this one. All right? All right. So, when we have that coulomb, then they can give you factors. They can give you what we call, the first one, normally they like microcoulomb, something like this, a microcoulomb. Do you see that?
Yes.
All right. So that funny thing, this thing, it is the same as 10 to the exponent of -6. Because when I used to buy a microwave, it was about 600, 700. So I remember it's a 6. All right. So I'm going to give an example how to convert that one. Then the next one is what they call nano. I call it nano, so that it sounds like 9 to me. Nano sounds like 9, eh? It is a 9. So it's going to be 10 to the power of -9. All right, so let me just write here. This one, it's micro. And then this one, it's nano. 9. You've been hearing about nanotechnology. Nah? Then the next one, which is going to be to the power of 12, they use a P. It's pico. PC. So that P, it actually stands for 10 to the -12. So I believe it's pico. You can go check the spelling and fix the grammar. I fix them numbers. All right, and then there is another one, you hardly do it, which is femto coulomb. It's an F. That one, normally they don't show it to you. It's 15. It's like 15, 50, anything that has a 5. Nah? You start with the letter F. So it's femto, that one. It's femto. So let's have an example quick. If they give me 3 microcoulomb, mathematically, right? I want you to understand, normally every time the last letter, most of the time the last letter, it's actually the units. It is not a number. The other letters that come before are normally numbers, like kilo, meter, millimeter, centimeter. So the meter, it's not a number. So it means there's a multiplication here. There's a multiplication here. But they don't show that multiplication. So which means when I change it, this thing, it's going to be 3 times. Yes, 10 to the exponent of -6 coulomb. Isn't it right?
Yes, sir.
If I were using nano, I'll put 10 to the minus that. Am I right? And so on and so on and so on. There we go. Okay, I'm happy because you can understand, because you are under the roof. Okay. So now, let's push on a little bit. So these are the type of calculation mostly they ask you, right? Then another type of calculations, because I'm going to give you A small rule. Let me give you something that you need to know. You need to know that one electron, remember electron is a charge, all right? It carries negative 1,6 multiplied by 10 to the power of what? Negative 19. Am I right, ne? Coulomb charge. That's how much charge it carries. Sometimes you can also write joules here. It's also joules also. It's the same number. So how about a proton? A proton is positive. So one proton, it carries it's the same number because it's a charge. It's the same number, right? But the only thing, we just put a positive sign. So it's 1,6 multiplied by 10 to the negative 19 Coulomb. All right, now listen to me. If you are given 2 electrons, they want to know how many charges are there. So that means you'll say 2 multiplied by 1,6. Am I right?
Yes, sir.
Times 10 to the negative 19 Coulomb. But you'll put it as a negative number. If we're dealing with protons here, you'll deal with a positive number. Exactly the same thing. The number of proton lost or gain will be the same number of electrons gain or loss. So if you lose electrons, you are gaining protons. The number will be the same. If you say, I lost 10 electrons, you gained 10 protons. Exactly the same thing. So every time when they say calculate how many electrons were lost, that number, it is the same number of protons gained. And even vice versa. You sharp, ne? All right. All right. It's like if you take 10 rand from me, how much you gain? How much I lost? You see? The lose and gain is the same. All right. I'll show you in the next video.